Fantastic. Well, everybody, thank you very much for joining me this afternoon. My name's Tom Millican. I'm the CEO of QiO Technologies. And today we're going to be discussing how data centers and the energy landscape that supports them as part of a wider digital economy is changing, as well as some strategies for adapting and being able to manage that consumption whilst bringing a more sustainable overall global economy to bear. So thank you very much for having me, and we'll jump right in. I think we can all say with some certainty that the requirement for computers is going to go up as we become more connected and more digitized throughout a wider spectrum of industries. What I think is underappreciated is the rate at which that growth in energy consumption will happen. We can see from this slide is that by 2030, 13% of all energy consumed will be consumed by the data centers, and subsequently the greenhouse gases produced to support that energy consumption threefold from 2022. Now, this isn't just a global issue. At a more regional level, 2.7% of European data centers energy is consumed, and that's, sorry, 2.7% of European data centers consume energy at that rate at the moment, and 1.8% of the US total electricity consumed is consumed by each of the data centers. I think what's really driving this, which this slide shows here, is that AI and its connectivity throughout our total economy is at its forefront. And as we see that expand, touching all areas of not only the data center specific industry, but more traditional sectors like banking, finance, advertising, the complexity and the number of touch points for those are going to increase, increasing that demand for compute. And I think this is very similar actually to how the bedrock of the internet was formed and the connectivity and how businesses had to adopt new business models to be able to respond to the usage of the internet. I think AI is going to have a very similar impact to how we engage with each other, how we engage in commerce, and how global trade's responsive for to the AI revolution, which I think we're at the forebed of. I think what's really important to also consider at this stage is that AI, as of today, is the worst it's ever going to be. And as large language models and the data becomes more complicated, connected, and complex, we're going to have much more requirements for compute, and therefore the demand for data centers and the subsequent energy to power those data centers have become a bottleneck for not only innovation, but actually global growth. And I think that's a really important thing to consider. We consume 460 terawatts of energy currently. That's predicted to double and then some by 2026. We currently consume 4% of global greenhouse emissions, and that's forecast to increase to 8%. What this really means is that as we increase the amount of energy we want to use for compute power, we're having a detrimental impact to the environment. We're having a detrimental impact to our businesses, as the total increase of energy costs has an impact on our bottom line, as well as our ability to grow the top line. And then actually, from a European perspective, investment in data center infrastructure is far behind where it needs to be. And whenever you're trying to catch up, everything becomes much more expensive and much more costly to accelerate. And what was once thought to be a problem only for the large public cloud providers, I think what we're starting to see is that there's a shift back to allow data centers in the enterprise space to future-proof their organizations by taking control of their compute and building and investing or repurposing on-prem facilities and private cloud facilities. I think what we've seen over the last couple of quarters is that real shift away from the elusive holy grail of public cloud could solve all of our problems to an actual more balanced stasis where a hybrid environment with much more balanced proportions between private cloud, on-prem, and public cloud allow companies to be more agile and take some of the flexibility of public cloud, but really distill it down into a more cost-efficient operating model, which combines the facets, including some of the other benefits of private and on-prem facilities, such as data sovereignty and security, with the flexibility and scalability of public cloud. Now, this is something which I think industry leaders have seen for or foreseen for some time. But to contextualize what this slide shows is not too long ago, there was a real market sentiment of a 90-10 split between public cloud and on-prem private cloud. I actually think we've seen that reverse. And whilst we're not expecting a full sentiment reversal, a more balanced 40-40-20 split is something that I think is going to be more prevalent in the market. And what I think that shows in this instance, to talk about the energy landscape, is managing all facets of the data center, including the incoming energy, is going to be the operator's responsibility, and the accountability for making those as efficient to drive down the cost of compute overall is going to be incredibly important for operators to allow their organizations to compete in a more connected, digitized, AI-led economy. I think that's something which is going to be really quite transformational, and those who are able to capture that early and build that infrastructure early are going to be the ones that are going to be compelled to win in the short term, whilst the remaining organizations are going to be playing catch up, which is always a tricky spot to be in. Wrong way. I mentioned before the global scale and impact of demand for compute, electricity to power those data centers. And what we're trying to demonstrate here is this isn't just a regional problem. Supply and demand globally are out of balance, and the demand which is forecast in the coming years vastly outstrips the ability for companies, organizations, governments to facilitate and build data centers at a fast enough rate to keep up with that demand. With that, expansion plans are often halted. We've seen in West London, there's been caps in terms of the amount of electricity to be available for more regional data centers on the continent to be able to expand. And that increases dramatically the risk of downtime, outages. It increases the price of compute and energy. And it means that the operating costs to be competitive in a highly data-driven AI-induced economy is going to exponentially increase. The cost of outages is widely considered to be around $6,500 per minute of outage. And as we see those outages increase, the problems and the reputational damage which come along with that type of outage is going to become particularly important. And whilst there are some measures or technologies available to reduce some of that impact at the moment, we're far from being able to get the consumption of energy down to an area where we can start to abate some of that imbalance between supply and demand. And this is seen across Europe, seen in America. We've got constraints in terms of building. I think the last conversation, I just caught the tail end of it, talked about the increase in regulation and whether or not that was going to be supportive or a blocker to further data center expansion. But I think what we can all unilaterally agree on is that at the moment, the demand for compute and the power from data centers, far outstrips the supply, which is becoming a bit of a bottleneck for growth. A number of key case studies where this has been particularly evident is obviously West London, which I mentioned, where the aging grid's preventing the expansion of new data centers in that region. I think that becomes particularly important for people who are trying to repatriate public cloud to on-prem private cloud. And I think what that means is there will be enhanced operational costs to support the logistics of finding greenfield sites and understanding the regional regulation within those sites to be able to really build something which is meaningful and has legs for the future to support that AI journey. But we see this across the pond as well in Northern Virginia, as well as close to home in Amsterdam, where there's caps being put on the amount of energy which can be drawn from the grid to make sure that there's that residual stability that allows other operations and businesses to use that electricity as well. Now, we're all aware of the tools, softwares, etc., that are in place or available to help manage some of the energy consumed throughout the ecosystem of the data center. But I think what's really prevalent here is, an ounce of prevention is a pound of cure. The real ability to reduce the consumption of the CPU themselves without impacting performance is really the essence of what all of the secondary energy optimization systems within a data center can really achieve. If we're looking to manage cooling, where there's lots of investment and cool things going on at the moment, that really is a responsive or reactive tool to the underlying heat produced by the CPU. And therefore, one of the really interesting topics for a discussion later on in this talk is really around how we can make the chips themselves more efficient with the energy, and then manage the CPUs with AI solutions to really make sure that the cost per dollar of compute is substantially reduced, and that impact throughout the wider energy stack is really refined, so that the CPU reduction in energy optimization translates to a reduction in cooling, a reduction in airflow. I think that transforms really from the source of the energy production, the efficiency of that ecosystem. I think at the end of the last talk as well, there was a discussion around PUE and the relative merits of that as a metric, and where that was focused on from a regulatory perspective. But from an overall efficiency perspective, reducing the amount of energy consumed at source, i.e. At the server level, is incredibly important to having an outsized operational impact on the overall data center ecosystem, and those in turn making each subsequent technology more efficient is really powerful. I think being able to do that in a very quick amount of time in collaboration with those incumbent tools allows organizations to respond to the changing dynamics of an AI-driven demand for compute without having some of the complexities or challenges with the incumbent systems. I think that gives organizations that could be considered somewhat less agile than others the ability to deploy technology in a way which is not only aligned with what their short-term goals are, but it would also support the market sentiment shift from public cloud and the high associated costs back to private and on-prem facilities, without having to go through the complexity of some of the other kind of tools or the long investment cycles for things like PMRs, integrating fully renewable systems into enterprise data centers. But you get a lot of the benefits retained of having your own facilities, such as security, data sovereignty, the ability to control cost and manage that environment quite tightly. And that's certainly something we've seen from the customers that we've engaged with are priorities, as it would be for many others. From a sustainability perspective, opposed to purely an efficiency view, the cooling and the airflow systems that are facilitating more efficient data center operations are critical for being able to have a more sustainable, less impactful footprint on the world. I think what's really important to recover or cover again here is that ounce of prevention is a pound of cure. The cooling system and the improvements made there are very much responsive to the heat produced from the CPUs themselves and the utilization that's being run through those servers. And whilst the innovation and the technological advancements in cooling are really interesting, the underlying production of that heat hasn't changed. I think what's really interesting around some of the AI tools, particularly that QiO has been able to develop, is really around improving the utilization rate of the CPUs and therefore having an outsized impact on the rest of that ecosystem, and making the chip itself more efficient improves the efficiency of cooling, improves the efficiency of the data center software used to manage the remaining assets within that ecosystem stack. And it means that any energy that is drawn from renewable sources certainly has a more impactful purpose on the footprint of that overall site, meaning that excess energy, even if it's from a renewable source, isn't wasted. And I think that's quite important, particularly when you're looking at your total cost of ownership, but also in terms of the carbon footprint of one's operation. I think this is just really the first step, right? I think everyone acknowledges that the future of data centers is going to look quite different. We're going to have to use a number of different solutions to provide a holistic benefit to be able to keep up with the demand for energy as part of the data center ecosystem. And it's going to touch on a number of different facets: the optimization and the chip technology, the supporting systems that are allowing the data center tools to really be as good as they possibly can be and as efficient as they possibly can be. It's going to require a change in how we look to power the underlying data center and the sources of that power. It's going to look at how that power is drawn from the grid and have a more wider infrastructural change on how we integrate with data centers and the way at which they intersect with the wider electrification of regions, particularly here in the UK. And we're also going to have to look at how we can expand the useful life of the current portfolios that people are operating on. We aren't going to have a replacement cycle that's as quick for either supply chain reasons or for technological advancements, and therefore that circular economy, the recycling of heat, the recycling and extension of life for CPUs, the extension of capex versus opex is going to be crucial for data centers to operate at a cost base which is sustainable, but is also able to grow with the growth in demand for the electricity to support those. Now, there's a couple of boxes on this slide which is going to segue quite nicely into the next one, which is around AI tooling and how that AI tooling can be deployed very quickly to be able to demonstrate savings and a very tangible return on investment. But I think what's really important with the software aspect is being able to deploy across a different array of hardwares is incredibly agile for organizations to try and keep up with that pace of innovation, and replacing and the opportunity cost of being able to change software as opposed to hardwares with a relatively low footprint is really important for people to be able to figure out what operating model works for them. So when I come on to the next slide to speak specifically on server optics, which we'll do now, and talk about how it's able to help owners and operators of data centers really get to grip with the efficiency of their underlying servers and really transform the energy per square foot consumed of those data centers. I think it's really interesting to see that difference between software and hardware. Now, what we do here at QiO is really quite simple. We deploy software onto the CPU to reduce the energy that CPU consumes. And as a result, we get a direct saving at the CPU level, but we also have a downstream impact on cooling and the subsequent HVAC systems to make sure that the whole ecosystem is optimized, because we've optimized the underlying source of that heat production, which the other softwares often focus on. Now, what's particularly interesting around our software is that it's very quick to deploy. I think our record time is 6 minutes for deployment, and we're able to see a north of 50% saving on a macro level within a matter of minutes from deployment. And the way that we do that is really simple. We predict the utilization, and then we make state changes based on the interpretation of that telemetry. And what we found is being able to deploy it in a very secure on-prem only manner means that the security concerns and the agility that often larger organizations are particularly focused on are abated. People are very keen to be able to have the data contained within their own firewalls. And I think what we were able to demonstrate with a solution like this is that actually it's not an all or nothing, that we're able to collaborate with other systems to make the whole ecosystem more efficient, and it can be done in a very agile way that allows people to see benefits today rather than a longer term a longer term payback period where there is much more fixation on how integrated it is with the overall ecosystem that's in place. Now, we've had a good amount of success with our initial customers. We've been able to demonstrate in real workloads the amount of savings that each of these different customers, ranging from 20 to 30% directly on the CPU, with an additional 0.7 watts saved per watt at the CPU level. And I think what's really interesting around this is that we've got quite a diverse spectrum of customers that we've been able to demonstrate these results for. I think what that's indicative of is not only how connected and digitized lots of businesses have become, but also that we're able to, if these are problems that everybody in the industry is facing, whether or not you've got a lot of servers or not, this is starting to become a priority issue for all operators to be able to get the costs down, reduce the carbon footprint, release capacity back to the grid, and really have an understanding of where and what those servers and CPUs are doing from an operator's perspective. That's tremendously valuable, particularly when we're able to disintegrate the GPU layer, CPU layer even. And it's really simple for people to get involved. Within a very short amount of time, we were able to demonstrate the value upfront to all of our customers. 10 servers is all it takes to kind of get a test base for what would be reflective of production workloads. And once we have that, it's very easy to scale up. And the beauty of software and it being completely contained within the customer environment is that actually we're able to get user value very quickly, get customers seeing those savings, and get those benefits in terms of your ESG reporting, your sustainability tooling, really quite sharp and pointy in a relatively short amount of time compared to different types of data center software, DSIMs or liquid cooling. And I open the floor to some questions. I'm a bit can't see anybody, which is always quite
yeah, so it's a bit disorienting, isn't it, when you can't
a bit
see.
disorientating.
Just quickly before we move on to the next session, thank you so much for joining us today, Tom. That's really interesting. I'm just going to turn over to questions. We've got enough time for a couple. So the first one is, we've had the question a few times today, but curious to hear your views on data centers providing heat for district heating purposes.
Very interesting. I mean,
it's sort of run through a lot of topics that we've discussed today.
I think operators of data centers are going to look for ways to get the cost per unit power down or cost per unit compute down. And if reselling that heat is an opportunity for them to do that, that's something which is going to be creeping up the priority list. The resale of heat, the transition to nuclear, the transition to fully renewable, and other aspects of that circular economy take a lot of time and investment. And actually, by the time we get to those taking traction, there may be an element that actually the industry has moved on and supply and demand are still out of balance. And what's really unique about server optics is that we're able to deliver that today so people can start to get some of those benefits of that lower unit cost today. They can reduce their carbon footprint today, and that frees up the opportunity cost not only of the operational teams, but the financial cost, the bandwidth of sustainability teams to pursue additional avenues to reduce that impact. So I think people will start to explore wider areas of that circularity. But there's certainly some opportunities for optimization close to home that could be easier, cheaper, faster to deploy with the same overall benefit.
Yeah, thank you. And then just one more question. Does server optics get regular updates? And if so, are any future features planned for the pipeline?
Yeah, so we do regular updates. They're currently coming out sort of monthly, which is really positive. In terms of the things that we currently do, we've obviously got the energy optimization suite. We have tooling that allows the reporting of sustainability within the platform that we have. So you can input your methodology for calculating your CO2, which is nice for your sustainability reporting. And then the elements around telemetry collected for that more circular economy slide that we discussed earlier, around where lifetime extension is certainly things we're really considering, looking at that value proposition. So the entire TCO of a CPU is going to be much more well defined, and our impact from a carbon footprint perspective, but also from an efficiency perspective, as we see the pressures mount on operators, is going to become vital for people having one single pane view of what, where, how their CPU is being operated on, and where the risks are for them. Because I think, as we can all agree, the outages and the increased demand on the grid are going to become quite big hurdles for us to overcome, particularly as we start to see an increasing growth of AI and things like that take its toll on not only just the hyperscalers but enterprises as well.
Brilliant. Thank you so much, Tom. That takes us perfectly to the next session. So thank you very much for joining us today. We really appreciate your time.
Thank you very much. Really appreciate it. Thank you very much.
Thank you.